and welcome to our YouTube channel. Today we're joined by a very special guest, George, who is a CNC technician at Lathe Engineering. Welcome.
Thank you, Jennifer. Thank you for inviting me at your YouTube channel. I'm a little bit nervous, really.
No,
But
just
for
relax.
me, I have to realize. For me, it's a pleasure talking with you about one of my hobbies, that is CNC. And yeah, I hope we got a nice interview and we can have a good chat about the CNC and everything.
Excellent. Yes, I'm sure we will. To start us off, could you tell us a little bit about your background?
Speaking about my background, and I started like a manual milling machinist, working with the old machine, big one, big machine. I was working with the tons of parts, pieces, huge, like 500 kilograms, 1 ton, and a lot of process, a lot of. I learned a lot. My first person who trained it was a Spanish. He called Paul, and yeah, he got the passion for teach me everything what I know in manual milling, and I was with him 6 months, and I learned a lot about the manual machines. Yeah, and my adventures continue in Spain as well. I was working in assemble molding, making moldings for cars like BMW, like Audi, like Volkswagen, like Renault. Yeah, we were making parts and molds for them, and I enjoy as well because it was my first experience on CNC, and it was well. It was entertainment, sometimes bored. But yeah, at the same time, we were working assemble and disassemble molds and adjust the molds. We were working with a heavy duty machinery and heavy weight parts as well.
It sounds quite complicated. I mean, we'll go into more about CNC machining in detail a little bit later. For somebody who's thinking of creating a part, they're obviously needing to, okay, they've decided they want to make a metal part. The next step is which manufacturing process would be best for them. Which type of products or parts would suit CNC machining? Or when would you choose CNC machining over another manufacturing process?
I think what I'm seeing there, we use CNC definitely nowadays for do everything. And some complicated part with drilling, I think we use manual machine, but a little bit. But compared with the past, definitely in the past, we combine in another companies, we combine manual with CNC, but now CNC is the best option almost for everything. Yeah, now if you go around any workshop, most of the manual and old machines are stopping. No one is working there. Everyone is working on CNC. Only a few things you can do there. Yeah.
And why is that, do you think, that the other processes have kind of died out in favor of CNC machining? What makes that so favorable?
I think it's because the CNC machine is doing the thing. Yeah. If easy and quick to set up the machine, and once you set up the machine and you adjust the tolerances and the machine is ready, only the process is do part quick, and I think that is why the company choose CNC, because it's exciting working in that kind of sector, but it's nice it's making profit for them as well. I prefer to stay up to date in CNC because this is the future, I think, and companies are creating more sophisticated machines than people like me, young, or even people who are studying CNC. That is what they want, and professors and teachers, they are preparing them for that. for the future. And I think the future is CNC. Yeah, that is why.
Excellent. And I know that with injection molding, there's often a big startup cost involved. How is CNC with regards to that? If somebody they wanted to make a prototype or their production volume is quite low, is CNC a good option, or does it become more cost effective when you have a higher quantity?
Depends of the person, and depends what they want to make it. But depends if of course most of people before to start to do a larger series with a huge quantity, they send prototypes first, and I think they try in the machine or I don't know, somewhere the part we're making, and if it fits, and they want to make in the company the parts, they decided. But definitely the first thing, if you start a job at the beginning, is the prototype, and after that depends of the customer. They decided how many parts they want or any.
Okay, excellent. And there's several kinds of CNC. Could you run us through those for somebody who wasn't aware of them?
Yeah. It's I mean, it's the CNC mill. You can make parts, and the parts you are making is with the tool, the rotating tool, and the part is stay in one place, tidy and adjusted. And the turning machine is making with the part rotating, and the tool is only moving. It's moving but not rotating. I mean the turning tools, yeah, and lathe tools, yeah.
Okay, what scenarios would you choose CNC milling rather than CNC turning, or vice versa?
I think we choose when it is not rotatory part, definitely is going straight away to milling machine because of cost of effectivity. And if you choose turning, maybe the turning lathe has to do with 4 axes, what includes milling as well. And even you can, if the machine is sophisticated, you can choose turning, because some machine is doing turning, milling, and it has head, and head is moving as well in the 5 axis, and you can do whatever you want in one only machine. But in a machine center like a CNC milling, maybe you have 5 axes, but you cannot run in the machine quicker than the lathe is doing if you are making a rotatory part. Yeah, that is why people in the office has to decide, but most decided if it's not rotatory part, is going straight to milling. But if even you can choose both, because sometimes a company doesn't have empty the machine what they need, and then you're making in one turning the first process, and the second process is going to milling, and yeah.
Excellent. And when you're talking about the programming of a CNC machine, how automated is that these days? Has that changed in the last few years? How much manual setup does it require, both in terms of the setup and the production itself? Is that getting more automated?
I think it's a huge difference between programming by myself and versus software, because of course operator can do programming quick, but something basic. But if it is something like aerospace components, definitely you maybe take a 1 day for programming a part, or maybe 2 days. Plus you have to adjust the setups of the tooling and everything. Then I think now company bet for doing the process with the software. And in our company, what I know, they send even the customer send the prototype straight to the company, and the company is only transfer the data to the software, and they choose the tools what they want to use, and the software is doing in seconds the program, and they transfer to the program. They transfer the program into the machine, and in the machine, the operator, for example, like me, only we have to set the tools and adjust we have to adjust the tolerances like the drawing says, and yeah, and after that we get the first up for inspection, and we doing the parts quick. I mean, cost effective, I think software definitely is the key nowadays, but it doesn't mean we cannot do the job.
So it's completely automated. Once the customer has the design, they send it, and the CNC machine, it goes directly to the machine that then programs it. And all you do is set the tolerance and kind of set up the machine to go.
Yeah, and yes, and sometimes we have to modify. Sometimes we have to add another tool, like holding tool, or sometimes we have to modify the advance, the feed. Sorry, the feed. Yeah, sometimes the software doesn't work with some type of tool what we need, and we have to set and do the program by ourselves. And yeah, after that, the important things as well when they send the program, and the office send the program into the machine, we have to check if there's no any collision or any G code in a wrong way. And then we have to be very careful, because we can break the machine if we don't realize what exactly we're doing. We have to be focused 100%.
No, definitely. I think that's something key to remember, that as we get more and more automated in this industry, it doesn't take away from the importance of people who are actually setting up the machine and in charge of the machine, because it actually makes your job even more important. And that's right, we can't rely on automation. And for those wanting to design a part at the design stage, which programs would you recommend that are the best for doing that?
For my own experience, because now I'm studying industrial design. I'm using AutoCAD and Solid Edge, and for me definitely for make solids is solids and drawings is Solid Edge.
And do you think they're both quite user friendly? If somebody's never used this platform to design a part, are they able to use it, or do they need some prior experience or learning about this software before trying to design the part?
Definitely, if you have some knowledge about the engineering, or you wanted to be into engineering, you can do by yourself. It's not complicated. If once you understand, you can get it. And how you understand day by day. If you are working, or you are around that world, the world of CNC and engineering, you are gonna catch quick. Yeah.
And yeah, excellent, thank you. Do you see any benefit then in, once somebody has designed their part, having an engineer look at that first before sending it off to a manufacturer for production? Do you see any benefit in that?
Yes. If it's some job, with something accurate, definitely they have to send into the engineer. But if they have to test it, they have to send another type of industry for testing, I think. But maybe they can set the prototype for the engineering. The engineering, we can fabricate it, and once he or the company takes the prototype, they have to send it to test it. Yeah, but definitely, when they have to change something, tolerances or something is not going well, you have to change the material or something.
Definitely. And are there anything a CNC machine can't do? For example, any rounded edges or certain tolerances, or what do they need to look out for that a CNC machine cannot produce?
But CNC definitely now is everything. I don't know, because we manufacturing everything, plastic, vinyl, carbon fiber, metal, steel, aluminum, even molds. Of course, molds is cheaper when you make the mold, but I think you can do plastic mold even in CNC. Depends of the cost, yeah. But speaking about the manufacturing, I think you can do it whatever you want in CNC. Like you can do in spark welding, you can boring, you can maybe no electricity, of course, but electricity components is gonna be a part what we are fabricating. Like we are doing, for example, we are doing aerospace components. And yeah, what you mix with aerospace, we mix with electricity. And the other company who is involved is maybe the lubricants as well. And the other company is doing the drawings, and the other company is doing the assembly. But definitely the mainly parts of the some companies making by manufacturing CNC, I think, yeah.
Excellent. So it seems like it's a lot less limiting than some of the other processes. For example, injection molding. CNC machining seems to be catering for a lot more options for a customer who's wanting to complete parts. And how about those who are in procurement? They're not engineers, they're just in procurement. They would also be using CAD/CAM and programs like SolidWorks to create their parts.
Yeah, they can use it. Yeah. For example, myself is an example of that. I've never used a 3D printing, and once I finish my degree, I'm going to buy a 3D printing, and I'm gonna try to buy a license of Solidage. Or if not, I'm going to learn how to use the software, what is coming with the 3D printing, for example. And I'm not afraid because I got I know there is some place where they're going to show me how to manage, how to do what I want to do with the 3D printer. Even the company maybe can offer me a course for how to use the 3D printing. Yeah.
Just to finish up with then, could you give us a brief outline of how it does work in terms of how the machine works? You mentioned it gets set up automatically from the drawing, and then you are programming it, the tolerance and the material, and then what actually happens?
And the process is, for example, if you want to do the programming by yourself, you're programming by yourself, you get a tool with the machine. When you get when you set the tools, because for avoid collisions, and that means when you use that tool, what is in the machine, you with that tool, are you saying to the tools where exactly in the position that is the tool, and after that you set in the part, you have to know and tell the machine where exactly is the part. And of course, you are not going to running straight away without check. In the panel control, you got the options. What that is going to you avoid for suffer yourself injuries and crash the machine as well. And once you know that, but definitely you need a years of experience of that. But machine actually they are so, how can I tell you, in terms of safety, the machine is very prepared for that. But yeah, that is the process. Yeah, but it's better if you watch it how the process is. But the process is like this. Is once you maybe takes 2 or 3 hours to make it apart, but when you make it well and you see it's no collision, you don't hurt yourself, then you can run in 100% feed and 100% of rapid mode. Yeah, that is. Yeah. This is
Excellent.
the process.
Yeah, that's really, really informative and very clear. Thank you. So thank you for all your insights today. I think it's been really, really useful and very interesting to hear your perspective, your background and your day-to-day work, and also your insights into CNC. So thank you very much for chatting with me today.
Thank you, Jennifer, for brought me about this interview. I was very excited to speak with you about CNC, and thank you for Heisel for this interview. And yeah, I hope so people can inspire if they watch this video, and I hope my little tips and my experience inspires people to do CNC and manufacturing. For me, is a good option for the new generations as well.